Today's video will demonstrate how to add asserts to code. Hello, I'm James Helfrich. I love asserts. They help me find bugs in code so much easier than I would otherwise. They notify me as soon as something goes wrong. The trick is, how do you put asserts into code so that you can find meaningful errors? This video will demonstrate that process. First of all, we'll start with what is an assert. An assert is a check placed in a program representing an assumption the developer thinks is always true. So we start with a simple flow chart. We have the assert condition. And if the assert condition is true, then the program continues as it normally would. But if it's false, then an error message is displayed and the program is halted. In other words, we stop as soon as any assumption proves not to be true. One way to think of this as a check engine light in a car. So you're driving along and suddenly the red light comes on, which means something is wrong. This indicates that one of many sensors in the car has detected that there is anomalous behavior. It is wise at this point in time to pull the car over and get it checked as soon as possible. Asserts are designed to look for defects in the program, not user errors. A user error is usually caught with a if statement and a while loop, and usually a user-friendly message. For an example, if you're driving your car and you start veering off the lane, then the car might beep at you, indicating you're veering off your lane. That's a user error. Asserts are different. Asserts are problems with the program itself caused by a programmer error, and these are the kinds of errors we want to catch with an assert. To demonstrate how this works, we'll take a look at a simple Java program trying to determine the sales tax for a given item. So we're given an amount and a rate as parameters. And right now we're just going to blindly compute the tax and return it. Well, there are some assumptions that we made here, and let's take a look at these. First of all, I'm going to give myself a little bit of space for my asserts, and I'm going to have some preconditions. In other words, I want to make sure my input parameters are correct. If my input parameters are not right, then everything after it's going to be bogus. So I want to have those asserts before I try to do anything, indicating don't look for the bug here, but rather look at the caller. Let's see here. I have two input parameters, amount and rate. Well, let's start with the amount. And if the amount is negative, well, any sales tax is clearly going to be bogus. So I'm just going to assert on that. And next, my rate. My rate better between 0 and 100%. Anything less than 0 is not a valid rate, and anything greater than 100% is also not a valid rate. Once again, if either of my preconditions are wrong, then I want to notify the programmer immediately, and that's going to tell them that someone called this function incorrectly. Next, I'm going to have some post conditions. I want to make sure my output is correct, and my tax better be greater than 0. And also, my tax better be less than the amount. If either of those are incorrect, then there's a problem with my tax computation. All right, let's take a look at another example. This function is going to return whether a given year is a leap year, and this one's done in Swift. And so basically, I have four conditions. I'm either between a quarter year, I am on the quarter year, I am on a centennial year, I'm on a quad century year. Okay, so let's give ourselves some space here, and let's start with the precondition. Now, it turns out this formula only works when I'm in a Gregorian calendar. If I'm before the Gregorian calendar, which took effect in 1752, then this program will be incorrect. So I'm going to assert to make sure my input parameter is right. It might be when I hook this function into the program that I want to use for, the Middle Ages or BC or something like that. In that case, I've indicated this function is not correct, and I'm going to have to write some additional code. But the important thing is this assert will tell me that there is something amiss. Next, and you might say this particular assert is trivial, but if I'm between quarter years, 2001, 2002, 2003, 2005, then I'm going to return false. I'm not a leap year. And I just want to make sure I got that modulus correct. Next, if leap year is not divisible by 100, and now this better be 1800, 1900, 2000, 2001, 2002, 2200, 2300. Anything before 1800 is not going to be a Gregorian calendar, so clearly I'm wrong there. And it might just be that I want to use this program for 2500 or something like that, but it seems really unlikely. So there is definitely a possibility for a false positive here, but I don't mind that so much because I just want to be notified when I'm going to get a year that is different than I expect. Okay. Year mod 400 equals 0. And that pretty much better be the year 2000. Once again, 22,400 might be one, but it's really more likely that if someone passed me a bogus year and I want to be notified that. And then otherwise, I better be between those years, 1800, 1900, 2100, 2200, 2300, and that's going to be my final years. Now, hopefully, it's going to be one of these four cases between a quad year, a century year, or a quad century year. But what if I made a mistake with my if statement? Then this assert will catch that. Now, notice, I do not expect that first assert or the last assert to ever fire because the way my if statements are set. But that's assuming this function is going to be remained unchanged. What happens 5, 10, 15 years from now? What happens if many developers came in and started modifying the code? Is there a chance they made a mistake? Is there a chance they altered the logic? If it's true, I want the assert to not only catch my errors, but their errors as well. So we definitely want to drop in asserts even when we don't think they will ever fire. I can't tell you how many times I've added asserts to code and I said, this will never fire. And then it did. And when it did, I was thankful because I learned something about the code and was able to easily fix the bug. This is example 5.1 and 5.2 in the Assert chapter of the software design textbook.